Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. Hope all of you are doing fine. So today we are going to start section number 3, that is hardware, and this section is quite long. It consists of many aspects of computer hardware. So in this lecture we would be studying about section 3.1 computer architecture. So the most central thing, the most powerful thing, the most basic thing inside a computer is a CPU, or the central processing unit, which basically is just a microprocessor. The CPU is the brain of all modern systems, including tablets and smartphones and any type of handheld devices. It is very often installed as an integrated circuit on a single microchip. It basically means the CPU, or the microprocessor, consists of only one chip and not multiple chips. You should those of you who are following the new syllabus, they should really learn this definition. It has the responsibility for the execution or processing of all the instructions and data in a computer application. A CPU consists of three parts basically: CU, or control unit, arithmetic and logic unit, ALU, and memory or unit, or you can say registers and buses. This is a von Neumann architecture of a CPU or a processor. This here is the memory unit. It consists of MAR, MDR and multiple other registers. A processing unit that consists of ALU and a register known as temp. Then a control unit with PC and IR registers and many other things. These lines are the buses which connect input-output devices with these three parts of the processor. You don't need to remember this diagram, this is just for your understanding. So the first thing which you need to know, whether you are following the old syllabus or the new syllabus, are the buses. Buses are the communication pathways through which data travels within a computer system, and they use parallel transmission. There are three types of buses: address bus, control bus and data bus. An address bus is a unidirectional bus. Unidirectional here is the keyword, that carries memory addresses from processor to memory. This is the second keyword. Whenever you are asked to define buses, then there are always two keywords to write in the answer. One is the direction of the bus, whether unidirectional or bidirectional, and the other is that which point to which point the data is traveling. A control bus is a unidirectional bus that carries control instruction from processor to all parts of computer. And a data bus is a bidirectional bus that transfers data between processor, memory and input-output devices. Okay. Another thing to know is that control bus, as long as we are talking about inside the CPU, then control bus is bidirectional, because processing ALU, MU and CU, they all communicate with each other as well, and when they are communicating with each other via control bus, then the control bus is bidirectional. But when the control bus leaves the processor, it goes out of the processor, then it becomes unidirectional. So control bus can be both unidirectional and bidirectional depending on the architecture of computer. This is a diagram of von Neumann architecture that shows buses. See, this is the address bus. It is unidirectional. It is going out of the processor and going in memory and IO systems. Then we have data bus, that is bidirectional. It has arrows on the processor side, memory side and IO system side. Then we have control bus, which has the arrows towards memory and IO devices, but not towards the processor, because secondary storage or hard drive or input output devices, they cannot send a command to processor. Only processor can send a command to these devices. Next, in the von Neumann architecture, we have some keywords of which you should know the definition. So let's have a look at them one by one. Registers. What is a register? A memory space that is used to temporarily hold data and instructions during processing. There are hundreds and thousands of registers inside a processor. MAR, Memory Address Register. It contains the address of memory location or the memory location where some data is stored. MDR, Memory Data Register. It contains the contents stored at memory location currently in MAR. This is also known as MBR, Memory Buffer Register. MDR holds the contents or the actual data that is stored at the address which is currently in MAR. These both work together. ALU, Arithmetic Logic Unit, part of processor that deals with mathematical and logical operations. PC, Program Counter, contains the address of memory location of next instruction to be fetched. CIR, Current Instruction Register. It contains the content of instruction currently being executed. IAS, Immediate Access Store, a type of memory or register that is used to hold data and instructions before they are processed. This is another name for RAM. ACC, Accumulator, a special register used by ALU that holds immediate results from an arithmetic or logical operation temporarily during calculations. Next we have Fetch-Execute cycle, whereas in the new syllabus it has been renamed to Fetch, Decode and Execute cycle. In order to carry out an instruction, the processor fetches data and stores it into suitable registers. It then decodes the instructions and executes it. This process is known as Fetch-Execute cycle or Fetch-Execute-Decode cycle. So what happens in a Fetch-Execute cycle? If you are following the old syllabus, then from here, then this is, you don't need to write this decode part. This is fetch and these both are included in execute. If you are following the new syllabus, then these 4 points are fetch, then the next point is decode and the next one is execute. So first of all, the address present in PC is moved to MAR via address bus. Content stored at memory location address contained in MAR is then copied into MDR. Instruction in the MDR is then copied into CIR. Value stored in PC is then incremented by 1, which becomes the address of next instruction to be fetched. These 4 points, these are the steps of fetch cycle. Next, the instruction is decoded, and after decoding means it is translated from high level language or from programming language into machine code so the processor can understand what to do. It is then executed via the control bus. Once the processor knows what to do, it sends signals via the control bus in order to execute that. This here marks the end of fetch execute cycle and computer architecture. If you are following the old syllabus, then this is pretty much the second part of chapter number 4, whereas for the new syllabus this is the first half of section number 3 of new syllabus. Next, 3.1.1 Performance and internal working of the CPU. We'll discuss this in the next lecture. Till then, take care. Allah Hafiz.